Hello everyone, welcome to the MSC Nastran 2024.1 What's New presentation. My name is Vicky and I am the product manager for MSC Nastran. Today, I am excited to share some of the latest updates and features in the MSC Nastran 2024.1. Let's get started. Let's dive into the key drivers behind MSC Nastran 2024.1. This release focuses on four main areas: performance and speed, enhanced user experience, new capabilities, as well as usability and solution enhancements. We're really pushing the boundaries to make sure you have a faster, more intuitive and powerful tool at your disposal. Let's explore each and every one of those in further detail. So we're gonna start by talking about the exciting new capabilities in the 2024.1 MSC Nastran release. We're introducing a brand new methodology for statically reducing superelements, offering up to 10 times faster performance. External superelement technology is a cornerstone of MSC Nastran, and we are now taking it to the next level by introducing the automatic multi-level static reduction technique. This new technique ensures identical numerical results to previous methods, but with significantly enhanced performance. The benefits are clear. You're gonna see significantly reduced overall elapsed times for large models in static analysis, plus the ability to process large A-set superelements, lifting the known limitations that are currently prevalent across the market. Continuing with our new capabilities, in MSC Nastran 2024.1, we introduced symmetry constraints in topometry optimization. By analyzing only a portion of the structure and replicating results across their symmetrical counterparts, we significantly reduce computational times, leading to faster analysis and design iterations. This ensures consistent, accurate results, even when boundary conditions or loads aren't symmetrical, reducing manufacturing costs and simplifying the modeling processes. In MSC Nastran 2024.1, we are excited to introduce our new high-performance nonlinear solver with a revamped Solution 400 architecture, which is really focused on performance. This release supports nonlinear static analysis and includes all 3D model space elements, materials, and contact features. The new DMAP flow reduces I/O operations and leverages shared memory parallel performance. We're introducing the MAMS solver, which enhances nonlinear analysis, offering increased performance in parallel scaling up to 32 plus cores with support for shared memory parallel, distributed memory parallel, and out-of-core capabilities. In our brand new high-performance nonlinear solver, we have added significant convergence monitoring features. A dedicated convergence messaging file called the iteration file provides at-a-glance a status of the iterations, increments, and convergence criteria. This GUI-based monitor updates continuously during analysis, making it easier for users to track the progress of the analysis. Benefits include not having to search through the output FO6 file for quick convergence information, as it's directly available in the iteration file. The singularity ratio is also reported, providing immediate assessment of the model's constraint status. Additionally, users have now a graphical tool for plotting convergence behavior throughout the analysis. In the node-to-segment contact problems, using the high-performance nonlinear solver in MSC Nastran 2024.1, an additional friction convergence check is now included. This check uses the ratio of the total friction force change in the iteration to the total friction force on the contact body as its tolerance. The friction convergence check provides extra assurance of convergence in the node-to-segment contact algorithm. Finally, in MSC Nastran 2024.1 and in our high-performance nonlinear solver, we now include arc-length convergence methods for jobs involving general contact. The key benefit of arc-length methods is their applicability to post-buckling behaviors, allowing these behaviors to be investigated in combination with general contact rather than being limited to glued contact. This feature is really essential for engineers who need to analyze complex post-backlit phenomena accurately and efficiently in their simulations. Moving on to the performance and speed features of MSC Nastran 2024.1. The MUMS sparse solver provides a state-of-the-art, highly scalable solution for systems of linear equations. Already integrated into MSC Nastran, this release enhances it with our out-of-core capabilities and distributed memory parallel support for normal modes and backlink analysis. This ensures that MUMS runs efficiently even on nodes with very limited RAM memory. The benefits are clear. It enables users with limited memory access and small clusters to fully benefit from the MUMS solver. Additionally, it reduces memory requirements when using MUMS with distributed memory parallel options. In NVH analysis, specifically in MSC Nastran PEM, we are introducing several performance improvements. MSC Nastran PEM considers the influence of porous materials or trims in a dynamic analysis using a coupled approach. Actran, the powerful acoustic solver, computes the impedance matrices based on physical properties and coupling conditions defined in the MSC Nastran input. To handle growing model sizes and performance requirements, in this release we're introducing a new method to compress the reduced impedance matrices in the model approach. The benefits are significant. Faster analysis of large models by compressing the rims within the model approach, reduced computational times with high accuracy, and minimized disk usage as well as input-output operations. Finally, in this release, we're introducing enhancements in static analysis performance. Users often identify minimum and maximum output quantities during a static analysis run, such as displacements, and check the epsilon value as well, which indicates the solution's quality. In MSC Nastran 2024.1, we optimized internal modules for these specific calculations in order to significantly improve the performance. The benefits are notable. We are reducing overall elapsed times in static analysis for large models with many load cases. And we have also improved performance for minimum and maximum output calculations, especially when parameters PRT maxim is specified in the input job deck. Now, let's move on to the enhanced user experience. In MSC Nastran 2024.1, we are introducing single-step transfer path analysis. Determining the key transfer paths from the source to the responses, such as tire excitation to a driver's ear sound pressure level, typically involves two separate dynamic analysis runs. In MSC Nastran 2024.1, this process is streamlined by integrating the two separate simulations into a single, faster, and more efficient workflow. This enhancement reduces complexity and eliminates the need to conduct separate analysis. The benefits are clear. The single job setup and submission for TPA analysis is streamlined, productivity is increased by eliminating the need to maintain and combine separate dynamic analysis runs, and the setup is straightforward, requiring minimal effort in the MSC Nastran input deck. Continuing with our enhanced user experience, let's talk about nonlinear cohesive elements. In MSC Nastran 2024.1, nonlinear cohesive elements are now accessible in linear solution sequences. Typically referenced in class type analysis, these elements can now be used in linear analysis by defining in plane stiffness and normal stiffness. These enhancements allows cohesive elements to maintain their elastic behavior in the model, eliminating the need for extensive modeling changes for linear analysis. The benefits include the ability to transition from class to other types of analysis without significant modeling changes and achieve greater results accuracy by modeling cohesive elements in linear solution sequences without any modeling approximations. Finally, in MSC Nastran 2024.1, we are enhancing the nonlinear frequency response solution sequence, or solution 128, also known as rotordynamics, by generating intermediate iterative solutions for divergent cases and introducing a new case control entry for providing displacement and nonlinear loads at each iteration's end for specific grid and degrees of freedom pairs. Users can now select a frequency range for desired outputs in a fully converged solution, enhancing post-processing capabilities to better understand and refine solutions through parameter adjustments. This update is ideal for engineers seeking advanced analysis capabilities across various frequency ranges. Let's now talk about usability and solution enhancements for MSC Nastran 2024.1. MSC Nastran version 2024.1 extends the real coupled modes method, which studies the dynamic behavior of coupled systems accounting for fluid structure interactions in heavy fluids. Building on the performance and stability improvements we introduced in version 2023.4, this version supports external superelements and introduces a new residual vector computation method to enhance the accuracy of model dynamic analysis. These enhancements improve performance for large-scale problems and result accuracy for dynamic solutions, making them ideal for engineers requiring advanced dynamic analysis capabilities. MSC modules in MSC Nastran is an efficient way for enhancing flexibility and reusability of components, facilitating model development and team collaboration without managing complex ID schemas. MSC Nastran modules are standalone bulk data sections representing parts of a larger assembly, such as a car wheel, a suspension, or an aircraft wing. Traceability and reusability of result files in modular designs are equally important. MSC Nastran supports modular results in single or separate HDFI files, and in this release, users can now individually append new results to existing HDFI files for each module. This yields multiple appended HDFI files for downstream processing and analysis, enhancing modularity and flexibility. Users can trace and analyze multiple runs of each modular component through a single file, perform downstream analysis and visualization of multiple runs based on selected timestamps, and leverage the open source capabilities of HDFI file output to manipulate results using open source scripting languages. In version 2024.1, a new MDSet entry is introduced to solve the problem of data recovery on MSC Nastran modules with overlapping IDs. Users can now extract specific results for each module without replicating the same results on modules with the same grid IDs. This minimizes data redundancy, avoids excessive data recovery, and decreases computational times during the data recovery process when only a limited number of modules are requested. For dynamic analysis, the peak-out capability in MSC Nastran provides an automatic way to detect response peaks in frequency response functions and extract additional results at the peak frequencies. In version 2024.1, equivalent radiated power, or abbreviated ERP results, are now supported in conjunction with peak-out, which has also been enhanced for better performance, stability, and robustness. This allows users to automatically calculate ERP responses at detected peaks using the peak-out command, eliminating the need of cumbersome manual work and improving the overall robustness and performance of the functionality. In MSC Nastran version 2024.1, we now support the direct recovery of acoustic pressure in atoms without requiring restart runs. The acoustic results are now embedded in the modal neutral file, abbreviated MNF file, utilized by atoms. This enhancement simplifies the prediction of sound pressure levels in atoms simulations by eliminating manual setup and multi-step processes. The Adams post-processor allows the recovery and plotting of acoustic pressure at locations of interest after performing an Adams transient analysis. This streamlines the workflow, decreases overall simulation time by skipping intermediate steps, and enhances efficiency and productivity by directly recovering acoustic pressure within Adams. Another modal neutral file or MNF enhancement includes the ability to have rotordynamic matrices results available in the MNF file for atoms. Aerospace and machinery manufacturers require multi-body simulations to account for gyroscopic effects such as stress stiffening and spin softening due to high-speed rotations. In MSC Nastran version 2024.1, users can now export an Adams MNF file containing the rotordynamic matrices, enabling Adams to capture local effects of flexible rotors undergoing high-speed rotations more efficiently. Activating rotordynamic computations is necessary during the Adams flexible body calculations. The Campbell diagrams for rotating flexible bodies can be plotted in the Adams post-processor, enhancing flexible body representations and streamlining the workflow by eliminating the need to divide flexible bodies into sections to capture nonlinear gyroscopic effects. Finally, in MSC Nastran version 2024.1, all key information regarding a signal run is summarized in the log file. Users can now find key model solution data in one single location without the need to scan all the additional FO6 and FO4 file of MSC Nastran, improving productivity and enhancing the readability of output files. A very important process for any solver is the ability to pre- and post-process simulation results. MSC Apex 2024.9 now offers complete support of MSC Nastran workflows. Let's take a look. MSC Apex 2024.1 introduces new support for MSC Nastran case control and solution sequences, focusing on dynamics such as frequency, transient, shock, and random response with both pre- and post-processing. This feature is available when importing MSC Nastran BDF or creating a new study in MSC Apex for the first time, offering expanded support for MSC Nastran solutions, comprehensive handling of various solutions, improved direct text input, job monitoring, and automatic results attachments for the external solver. The new features also enhance the capability to solve nonlinear analysis with MSC Nastran. Available when importing MSC Nastran PDF or creating a new study in MSC Apex, it offers expanded support for non-linear solutions or Solution 400, chain analysis, load combination improvements, thermal structural analysis, and conversions of legacy MSC Nastran decks such as Solution 106 and 153 to Solution 400. Additionally, it provides partial support for converting Solution 129 and 159 to Solution 400, scripting support for easy nonlinear analysis, contact management, and visualization of gaps or overclosures causing convergence issues, enabling engineers to visualize and correct problems for third-party FEA solvers. Finally, in MSC Apex 2024.1, users have direct access to Nexus Compute, the cloud-powered solution of Hexagon designed to turbocharge solver execution for MSC Nastran heavy computational tasks. This feature unlocks unparalleled performance for running large, complex MSC Nastran jobs and boosts productivity as users can now seamlessly submit jobs directly to the cloud via Nexus Compute from within the MSC Apex interface. A new Nexus push button in the MSC Apex interface allows quick cloud connection where compute requirements can be specified within the study tab during the creation of an import MSC Nastran job deck. Job results are automatically imported back to the user interface, providing significant benefits when processing large computational jobs. Users can submit jobs to the cloud without leaving their favorite user interface, access unlimited HPC resources directly, and benefit from flexible pay-as-you-go pricing. Let's now talk about previous release highlights. Our 2023 release highlights include performance improvements for real coupled modes and the integration of the MAMSO solver for dynamics runs. We also introduced RBE leg trimming, which drastically enhances the speed of models containing a large number of RBE3s. Additionally, we implemented virtual SEA or virtual statistical energy analysis, fluid structure coupling, and nonlinear frequency response or Solution 128 QR decomposition for increased solver robustness and stability, among others. Furthermore, we introduced a new way to reduce the memory requirements for ACMS, our fast eigenvalue solver, as well as further Solution 128 robustness improvements. A notable feature includes the ability to automatically extract operational deflection shapes or ODSs from peak out functionality directly without the need to set up additional subcases. For additional resources, feel free to explore our Sim Companion website. It serves as a comprehensive hub for all things MSC Nastran, offering access to documentation, user forums, discussions, and webinars to enhance your expertise. Should you need immediate assistance or frontline support, it's just an email away. For licensing inquiries, you can find the relevant contact information on this slide. For any inquiries related to MSC Nastran, feel free to reach out to me, Vicky Tsianika. I'm the product manager of MSC Nastran, as well as Hemant Patel, the head of development for MSC Nastran. Thank you for your attention, and I really hope you enjoy exploring the features of MSC Nastran 2024.1 release.